Hi guys, we're on our last new lesson of the chapter, which is setting up and solving word problems. In our two videos today, I will show you 4 different types of word problems, and we'll practice how to set them up. We will not be practicing how to solve word problems today, because once you've set up the word problem, the solving is like what we have been doing: substitution, elimination, sometimes graphing, but not usually. And so I'm going to focus today really on how to write the equations. And if you can write the equations correctly, I have faith that you can solve them. If you printed out the worksheets, we're going to start with the first page for the first video. And then for the second video, we'll fill out the second page. We're going to start right on top in the box that says helpful hints. So here are some helpful hints for you. First of all, make sure that you're defining your variables. That means that you're telling me what the X and the Y stand for. What do they mean? Make sure to be specific. For instance, are we finding out how much a child ticket costs? Or are we finding out how many children tickets somebody purchased? Those are two very different things that can get very different answers. The cost of a child's ticket, it would be appropriate to get a decimal answer. Maybe it's $6.50. But the amount of children tickets, it would not be appropriate to get a decimal because you can't have 6.5 tickets. So make sure that you know exactly what you're solving for. When you're reading the problem, you're going to look for specific words that will help you. The word each and the word per mean that that number will be multiplied by a variable. So anytime you see the word each or per, that's a number that should be right next to one of your variables. And the teeny tiny little word is usually where we write the equal sign. Usually on the other side of the equal sign, we'll put a total. When you're writing your equations, make sure that you're using each number from the word problem only once in total in the whole problem. So you can't use it once in the first equation and then use it a second time in the second equation. Every number should only be used once. Before writing your final answer, make sure to reread the question. This will be very important when you're doing your Delta math problems, because on the Delta math problems, it usually just wants one of the answers, not both of them. So after you've solved for X and Y, figure out which one does it want to know. Does it want to know the X, or does it want to know the Y, or maybe it wants to know both? And then finally, for our worksheet homework tonight anyway, you should make sure that your answer is restating the question. So if the question says, how many children tickets were purchased? Then you would say, we purchased 7 children tickets, right? So make sure that when you're answering a word problem, that you are writing words for your final answer. Continuing on our first worksheet, we're going to learn our first 2 types of word problems. If you did not print out the worksheet, don't worry, all this information is on the PowerPoint. You're just going to have to do a little bit more writing than if you didn't print out the worksheet. So let's start with our first type of problem, which is called a break-even problem. A break-even problem is when you have, when you are making a product and then you are selling it, and you're trying to figure out, when will I have made back the money that I spent on it? When will I break even? Right? Because usually when you start a business, you start in the red. You have to spend money to make money, is what they say. And so this is trying to figure out, when do I actually start going from losing money to making money? That's a break-even problem. In this problem, your X is always going to stand for a length of time. How many days? How many months? Sometimes we measure a length of time based on how many products we have to sell. So how many notebooks do I have to sell? How many bracelets do I have to sell? Something like that. And then your Y will always represent money. Depending on the equation, it'll represent either the amount of money that you spent or the amount of money that you made, but it always represents money. When you're writing equations for a break-even problem, you're going to write them in slope-intercept form. Y equals mx plus b. Your M is going to be a repeating cost. So something where every notebook that you make, you have to spend this much money. Or every bracelet that you sell, you make this much money. So M is a repeating cost. Again, you're looking for that word each or per, since it's being multiplied by the letter X. And then your B is a one-time cost. I had to buy the materials and it cost this much money. I had to rent an office space and it cost this much money. So that's a one-time cost. Your first equation should represent any money that you spent creating your product. And your second equation will represent how much money you make by selling your product. Based on the format of these equations, since they will both be in slope-intercept form, you could graph them, or you could just do substitution. When you're doing substitution, you're substituting one equation into the y of the other one. So basically, you're just going to set them equal to each other. Break-even problems will always ask you, when will we break even? Since it's asking you, when will we break even, it's looking for just the letter X, that length of time. So you would say something like, we will break even after 5 months, or we will break even once we have sold 150 bracelets, something like that, okay? So this is the generic information you need to know about a break-even problem. Let's take a look at an example. Again, we're only going to set up. We're not going to be solving during the video. This is the example that is typed on your worksheet, or if you don't have a worksheet, you want to write this down. This example says a puzzle expert wrote a new Sudoku puzzle book. His initial costs were $864. Binding and packaging each book costs 80 cents. The selling price of the book is $2. How many copies must be sold to break even? So in this problem, again, the y is money and the x is how many copies of the puzzle book he's making. For our first equation, which is how much money we spent on this new company, we spent a one-time initial cost of $864. And every time we make a book, it costs 80 cents. So our equation for the money that we spent is y equals 0.80x, remember x is how many books we're making, plus my initial startup costs of $864. That's my spent equation. For my equation about how much money I'm making every book I sell, I'm making $2, so it's going to be 2x. And then usually on the money that you're making equation, you don't have a one-time money over here. Unless somebody is like donating to you, you're not going to have a one-time thing. You're just going to make however much you make off of each book. So for my made equation, it's just y equals 2x, and it's okay to not have a plus b for the money made equation. Okay, so this is the setup. Again, if you were going to solve this, you could substitute this in over here. And then once you've solved for x, then you're done. In this problem, since it's asking you how many notebooks do you need to, or how many puzzle books do you need to sell to break even, your final answer would be, he needs to sell, I don't know, I didn't solve this, 250 puzzle books to break even, right? So just find your x and then you'd be ready to write your answer. This is our first type of word problem. Our second type of word problem is called a travel problem. In these problems, you will be traveling in two directions. You will have a starting point, you will go somewhere, and then you will come back to your starting point. So traveling to somewhere and back. In the travel problems, the x will always represent the speed of the object that is traveling. So if it's an airplane, then the speed of the airplane is your x. Or if it's a boat, the speed of the boat is the x. Or if it is you walking, how fast you can walk, right, is the x. So it's the speed of the object traveling. And then in each of these problems, there's going to be an external force either pushing or pulling the thing that is traveling. And that's what the y is going to be. The y is the force pushing or pulling. So for instance, when you're flying in a plane, the wind is either going to push you back and make you not go as fast, Or if you're traveling with the wind, it'll push you forward and make you go faster. If you're in a boat, you can travel with the stream and the stream will help you and push you along, or you can travel against the stream and the stream would push back at you. Okay, so y is the force that is pushing and x is the thing that is moving. These equations will always be set up the same way. One of them will be x plus y, and that should equal the faster number because that means that the airplane is flying with the wind and the wind is pushing it and making it go faster. So x plus y equals the faster speed. And then your second equation would be the opposite where the wind is pushing you back. So that would be x minus y. So you're flying in your plane and the wind is pushing you back. It's not actually pushing you back, but it's making you go slower. And so that one would equal the slower speed. So in these problems, you're only going to be given two numbers, and those numbers have to go after the equal sign. This problem is already set up for elimination. In fact, right now, my letter y's are going to eliminate. So as soon as you've written the equations, you just eliminate. The most common mistake on these problems when you're eliminating is forgetting to add your x's together. So make sure this is 1x plus 1x and make sure that that turns into a 2x. So if you're going to make a mistake on these problems, it's probably that you forgot to make this a 2x instead of just an x. If they don't tell you the speed, if they tell you they traveled this far and it took them this many hours, you can calculate the speed by dividing the distance that you traveled divided by the time that it took you to go that far. So if they don't actually tell you the speed, you are able to calculate it. It's distance divided by time. And then again, that is what goes over here after the equal sign. Let's take a look at the example on your paper. So this one says that a kayaker is paddling upstream from a camp to photograph a waterfall and then they return. The kayaker's speed while traveling upstream means that they are going against the current, is 4 miles per hour. And then the kayaker's speed while traveling downstream, that means that they're traveling with the current, is 7 miles per hour. What is the kayaker's rowing speed? And then what is the speed of the current? So just a reminder that the kayaker's rowing speed, that would be the speed of the object, and that's always going to be x. And then the current is the force pushing it, so that's going to be y. So the rowing speed is x and the current is y. Our equations are always x plus y and x minus y. In this problem, x plus y would be traveling downstream, the faster of the two, which is 7 miles per hour. 7 is faster than 4. So traveling upstream is when the current is pushing against you and making you go slower, and that would be the 4 miles per hour, and that would be x minus y. So the speed of the kayak minus the speed of the river pushing against them, and that would be x minus y equals 4. And then if you wanted to continue to solve this, you would use elimination. This one is asking for both the kayaker's speed and the speed of the current, so make sure that you are getting both answers if this was a problem on your homework. This concludes our first video. In our second video, we'll learn 2 more types of problems and how to set them up. Those are both going to be money problems. But until then, I'll see you later.